Okay, hello everyone. This is week 5 of CS201, Introduction to Computing. We will continue with something that we did last week. Just to warm you up, I want to warn you, things are getting harder, and today fasten your belts since we are going to cover quite a few topics. Important topics, which are very important to you to understand, and they are not easy if you don't pay attention. I don't want to frighten you, just I want to warn you that it's going to be easy if you pay attention, if you ask and try to understand everything in class, okay? So, firstly we are going to cover 2 short examples, but we didn't do that last week. You remember the truth table and the logical operators when we had 2 statements, A and B. And A could be true or false. Also B could be true or false. We had the logical operator, and those logical operators helped us to make more complex statements that can be true or false. What did we say about A and B? If they are both true, that both of statements are true, then their logical AND, by the way, this is how we write logical AND, is also true. If one of them is true, the other one is false. So this is true. If one of them is true and the other one is false, what is going to be the overall result? If I say, I am a boy, which is true, and I'm 10 years old, which is false. Overall, how is this? It's going to be false. Yeah. Same applies to this statement, and of course, if both of the statements are false, they are going to be false. Now, let's start a new project. This is important to know since sometimes, I hope this screen is better, black and white, if this is like that. So we have changed the theme, the skin of the Visual Studio. Let's start with the example. And let's copy paste those 2 examples for the time being. Copy. I'm going to paste them to the solution folder. And I'm going to add the first one. Existing item. The AND. Short circuit AND. Okay. This is the code about the short circuit AND example. Let's see what it's doing. You can see it, yeah. Okay, let's not forget this stuff. C in ignore and C in get. All right. Now we have 2 variables, x and y. They are both integer of type integer, as you can see it here. And we are trying, firstly, we have one statement, which is y is not equal to 0. This can be true or false. We have another statement which says x modulo y, or the remainder, when x is divided by y, the remainder, x modulo y, is greater than 3. If this is true, the logical AND of those 2 statements, if it's true, we're printing this tab. Otherwise, we're going to print this one. Now, before compiling it, can you tell me what is going to be the value of this statement here, of this if? So, x is 5, as you can see, y is 0. And the overall statement is going to be what? Why? Y is not equal to 0. Is this true? No. Since y is equal to 0, this is going to be false. What about the other statement? I'm saying x modulo y is greater than 3. Is it true or false? So x is 5, y is 0. When 5 is divided by 0, the remainder of this division is greater than 3. Is this true or false? What do you think? Why do you think it's false?
The computer can't generate the
You can generate
the computer can't generate.
So automatically you say when it's not, if you cannot generate it, it's false. Why you cannot generate it?
Because you're trying to divide something to 0.
Exactly. Division by 0 makes no sense. Okay? So this operator, modulo operator, always uses division. But when we divide by 0, do you remember from last times what happened? You remember the exceptions that division by 0, fatal error. We cannot do it, and the program stopped. Okay? So let's see. Let's run the program. Actually, we're expecting an error, but do we get one? Let's see. And let's see why. Why yes, why not? We are running the program now. Let me change the font so it can be easy viewable. Y is 0. This is the output. Meaning that this statement, correctly, it's false. If this is false, this is not going to be executed. So we go to the else clause, and this is going to be executed. Okay, it's true. We didn't have any mistake here. Everything is fine. Now let's do something interesting. Let's change the places of this statement here and this statement. I mean, we're just changing, swapping the places. That's why we have that code already here. I'm going to uncomment it. It's here. You see, x modulo y is greater than 0, it's here, and y is not equal to 0, y is not equal to 0. Basically, it's the same statement. You might think so. And it is, in a way. Let's comment out this part. And now let's run the code. What would you expect? What should we get? I mean, we just changed the place, nothing else. This should be false, because this is false, okay? If you go in according to some logic, it's going to be false. So, what should we get here? What do you think? We're going to print this one or this one? Come on. No idea? You can try it.
It's going to be the same result.
The same result. In a way, you are right, but not really. I mean, your logic makes sense because it's the same statement, but see what's going to happen. An error. And what's the type of the error? Integer division by 0. So you might say, okay, well, what's the deal here? Why do we have double standards?
Well, the computer is lazy and it ignores the error-rich code if the first one is like false.
Fortunately for us, computers are not lazy as humans.
Yeah, but if you're doing an AND statement and the first one is false, then the computer automatically ignores the second one.
If you think that one, yes, you're right, okay? But the humans program the computer, and computer is doing exactly what the humans are telling them. And the humans told exactly what you're talking about, okay? So here it goes. Before explaining this stuff, why did we get this error here, and why we didn't get it previously, let's go to this table here. If one of the statements is false, whether the first one or the second one, what is going to be the end result? True or false? It's going to be false. That's why what the computer did previously is it just checked the first statement. It was false. Basically, we had this one. The first one was false. So we don't care about the second one because we have and in between. Even if it's true, the overall statement, the complex one, is going to be false. If it's false also, it's going to be false. That's why it's not going to be checked, okay? For these reasons, we didn't have this error here because we didn't make any division here. We didn't need it to, okay? This was false, and I don't care about the other one. But here, we always start from left to right. So this is the first statement. We have to make a division here. Okay? But the computer doesn't know what's the value of x and y. We can give different values. So here we are dividing by 0, and it's a mistake. That's why we got this error. Okay? Try to pay attention to this one, because sometimes you are going to write if clauses like this. And here, or not here, let's say here, this is going to be false. And here you might write a statement like x is equal to 3 greater than 5. and 3 greater than 5 is false, and you expect that if x is a Boolean value, you will expect that x will be false also. But it's not going to be the case, okay? So again, you might have an expression here, you might print even something here, you might calculate here, but that calculation is not going to happen if the first one is false. Okay? And you think, okay, I did the calculation, so I didn't have it. Because it wasn't checked, since the first one was false. So pay attention to this stuff. Now, let's write the truth table about the logical OR. So this is AND. And this table here is about OR. We write it true and or true or false. Usually it's written ones and zeros. Let me check it with ones and zeros. So we have 1, 1, 0, 0. This is the best way to do it. 1, 0, 1, 0. You should get used with binary numbers. So true is equal to 1, and false is equal to 0. Sometimes I write 0 like this with a dash, in order to distinguish it from O. Okay, so 1 is true, 0 is false. True or true? What's going to be? It's true, yeah. True or false? If I say, I am a male, which is true, and I'm 10 years old, no 10, or I'm a male, or I'm 10 years old. So the first one is true, the second one is 0. Overall, it's true, because I have OR. What about the second one? It's true again. And the third one? We have 0, since this is false. If both of them are false, the overall statement, the logical OR, is false. Okay, let me remove this stuff.
Does it do the same thing here?
Let's check it. What do you think? What's your opinion about that?
Probably.
Yes, you're right. So we have short circuit OR. And we have basically exactly the same issue here. Okay, so we have x and y again. X is 5, y is 0. Now instead of writing not equal to 0, we are writing here a statement y is equal to 0, and the second statement is the same. And x modulo y is greater than true. Is greater than 3. Is it true or not? And we have an OR here, not an AND. Okay, let me run it. Let's not forget this boring part. Seen, ignore, unseen, get. Okay. We are running the code, and we get that 5 modulo 0 is greater than 3. Why do we get it? Since this one was evaluated as true. Why it was evaluated as true? Y is equal to 0, but this is not the assignment operator. If we have equal, equal, it's a logical operator, okay? Relational operator. Is this true? Yeah. If this is true, let's go and check the table. If the first one is true, regardless of what the case will be the second one, it's always going to be true when we have an OR expression. So that's why we're not going to check this guy. So if this is true, we are going to print this stuff here. Let's swap the places of those two, as we did previously. I'm going to uncomment it. To comment, no. Okay, to uncomment this guy. Why it's not? Yeah. And I'm going to comment this stuff here. So basically, we just swapped the places of those two. Now, we are trying to divide 5 and 0, since x is 5, y is 0. And division by 0 makes no sense. That's why we have this exception. You'll see what's exception in CS204, if we are going to take it. Okay? So basically, if the first statement is true, we know that the overall OR is going to be true, That's why we're not going to check it. And this is important, since sometimes, as I told you, you might have expressions, calculations, printing stuff, etc., etc., and you're not going to execute it, since this is how the computer works. Of course, if you write your compiler, you might say, okay, I don't want my compiler to write that way. Yeah, you can make your own language, and in your own language, you can make them evaluate both of them, okay? But this is how C++ works. C also works this way. I think Java also, C#, and a lot of languages. So pay attention to this stuff. Okay.
Can you make it so that if there's like a division by 0, you make an if clause?
Yeah, of course, you can do it.
Display error.
Yeah, I mean, you can handle it in different ways, tens of ways. And we will see it. I don't think, yeah, you will do some checks with if clauses, but you will do it in much more optimal way, advanced way, not with if clauses. They are called, by the way, one of those ways to handle division by 0 is called exceptions. You'll see what's that. I don't think we will do it in CS201. It's kind of advanced topic. Okay. Now I'm going to write a piece of code. Any questions about this one? No questions? I'm going to write a piece of code, and we are going to see something important, and that important stuff is called references. Okay, you shouldn't write this stuff. You should just follow me. So I'm adding new item. Let it be source CPP. Just follow me and try to understand what I'm doing. Okay. Include IO stream as usual. Using namespace std. All right. Now let's go to main directly and write something like this. I can have a seat while writing this stuff. Cout. This program shows how references work. We will see what's that. We have two variables, A and B. We are reading them, give A and B. So we are trying to read them. Okay. Now, what I want to do, after reading A and B, I want to swap their places. Swap meaning change. The value of A should be B and value of B should be A. For this reason, I'm going to use a function, and I'm going to call this function swap, normal swap. We will see why I'm calling it normal swap. It's going to be void because I don't want to return anything. I want normal swap only to, okay, number 1 and number 2. I want normal swap only to exchange the values of A and B. So how I'm going to do that? I'm passing A and B as parameters. So let's say in normal swap function, they are called number 1 and number 2. I'm defining a new temporary value, which is called temp, and I'm saying this guy is equal to number 1. Then I'm saying that number 1 is equal to number 2, and number 2 is equal to temp.
It's
Yes?
hard to
So it's better with the light one, okay? Okay, if it's harder, let me change the theme into the light one. Okay. Thank you for pointing it out. Okay, hope you can see it now. That's not, I mean, let's give the same names, A and B. So, I want to exchange the values of those two guys, of those two. Okay. Now I'm going to print this one. Cout in main before calling normal swap. And this is very critical. This is very important to understand. So I'm printing A and B here. I'm saying A is equal to, and I'm printing A. Then I'm saying B is equal to, and I'm printing B.
Printed B twice.
Yeah, I will correct it. Now I'm calling normal swap, and I'm sending A, you see, normal swap, takes A and B as parameters, A and B, and I expect those two guys to be exchanged. But also, let's do the same stuff here. When I call this function, let me copy paste this piece of code. I'm copying it. Okay, copy. Pasting it. So we are in the function normal swap. In the beginning. Okay. Again, we are in normal swap in the end. You see that this function has void here. It means that we are not returning anything. So, let me write this also in main after calling normal swap. This is it. Cin ignore, cin get, and return 0 for the main. Let me run the program, but let me also use breakpoints, and we will see. First, let me run the program. We will see that later on. So I'm running the program. And I'm giving A and B. Let's say A is 5 and B is 100. You see, what do I have? Let's compare the output with what's going on. So, we are here, this program, blah, blah, blah. We printed give A and B. We gave the 5 and 100. Now we're printing in May before calling normal swap. We see that A is 5 and B is 100. Now we call normal swap, and we send A as B as parameters. So we are here in normal swap. In the beginning, A is equal to 5, B is equal to 100. Then we swap those two, okay? A becomes B, B becomes A. We print them again in normal swap in the end. A becomes 100, B becomes 5. The function finishes, and we go here in main. In main, after calling normal swap, we print A and B. A is 5, B is 100. So you might expect, okay, we changed their places. Why they're not changed in main? Can you tell me why? You remember the scope? Just let me refresh your memory. This is probably one of the last times that I'm going to write something on the table. I will, but not very often. Main. So let's go and see the code line by line. What's happening and what we want to happen. This is the output. What we will see as an output. So we declare two variables. In the beginning we say this program, blah, 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 this. Then we declare A and B, two variables of type integer. This is A, this is B. I say A is equal to 5, I gave it as an input, and B is equal to 100. Then I'm printing here, before calling normal swap. A is 5 and B is 100. Now I'm calling the function normal swap. A normal swap has two integer numbers which are also called as A and B. But this A and this A are not the same. This A is the A of main, this A is the A of normal swap. So when we call this function, yeah, we might send A and B as values, but they actually are cloned here. They have the same name because we put it here to be so. The same value, but they're different parameters. Okay? So we printed this guy. Now we are calling normal swap and sending A as B as values. When we send them, we are printing this stuff here. In normal swap, blah, blah, blah. So we are in normal swap. In the beginning, we see that A is equal to 5 and B is 100. A is 5, B is 100. So far, so good. Then we do this weird trick. We define another variable which is called temporary, temp. It's also integer. We say that temp is equal to A. So basically we have 5 here. Then what do we say? We say that A is equal to B. Basically A is equal to B. We have 100 here. This is very important to watch and understand and see, okay? You will need this in CS204 and until the end of CS201. We will use it this week a lot until the end of the semester, really a lot. This is a very important issue. So temp is equal to A, previous A was 5. A is equal to B is 100. And I'm saying that B is equal to temp. You saw the code. So B becomes 5. Now when I'm printing A and B, I'm printing the function. So we did these 3 lines. Now I'm printing this function here, okay? In normal swap, in the end. So normal swap. In the end, A is equal to 100. B is equal to 5. I don't care about temp. Now the function is going to finish. We don't have any line. We don't need to write return because the return type, the value is void. We don't have to return anything. And remember, this is very important. When we are about to finish, everything that is associated with a normal swap function is erased from memory. So this is erased. Everything is erased. And we continue to execute our code where we left. And we continue immediately after normal swap. Okay, so it's here. We are in main again after calling normal swap. So we print this in main after normal swap. And we are printing A and B, which are 5 and 100. So A is 5 and B is 100. Okay, so the function didn't have the property that we desired from it. Since we desired the function to swap the places, swap the values of those variables, and see those changes inside the main, but we don't see them. So do you want me to show a way when you are going to make changes in another function, you want to see those values in main? Yes or no? I mean, let's say you have to write a program and you very often swap places, A and B. Okay? But if you do it like this, you won't do anything. Okay? So can you give me an idea? How would you do it? I'm calling another function. That function swaps the values, and we see those changes in main when the function that we just called finishes. An idea? What if I do something like this? I call another function, and instead of making new clones, new copies of A and B, I just use the same A and B. I might give another name. I might call this one number 1, number 2, but it's the same value. This is the same box. Okay? It's like giving aliases, giving different names to the same variable. And yeah, this is the way we are going to do it. And in order to do it, we are going to use something that is called reference. Basically, the new function is going to reference the original values without making a copy. So if you make changes here, those changes will be visible even after the function finishes. Let's see how I'm going to do that. So this was normal swap. Yeah.
Why is making copies bad?
It's like this. We call the function, we swap the values of A and B, but we want those values to see in main. Okay?
So you don't want copies, but you want the original.
Exactly.
But I don't understand why you want the original thing in the first place and not the copy.
Because you want to swap A and B. Okay? Yeah, you can do it in main, but I want to do it with a function. Okay? Because I might do it like thousands of times, and instead of writing this thousands of times, I just write it once and call it whatever I want, okay?
So it's a memory machine.
Kind of, you can say. All right, so let me, but not only a memory issue, you will see it, there's even, you cannot do it in other ways. You will see it in the third lecture today, why we should use this new technique. So let me write a new function which is called referenced swap. It also takes two variables, integers, but those are references, meaning we don't make any copies. We just use the same variables that we have been called with. And how do we distinguish, how do we know that it's a reference or not? It's with this sign here. It's called the ampersand, okay? If we have ampersand that we don't make new copies, we are just using the copies that we have been called with. We are referencing them. Okay, so after calling normal swap, now I might say something like this, cout, calling referenced swap, and line, and I'm calling it, so referenced swap, I'm calling it with A and B, but those you see here, they are references, they're passed like that, and now I'm printing in main, after calling not normal but referenced swap. Okay, so basically the function will be the same. That's why I'm going to copy paste this piece of code. So we are in referenced swap. Now let me run the program and see what's happening. Okay, I'm giving 5. I'm giving 100. Now you see, after I'm calling reference swap, in the end we have A is equal to 100. This is in the function, but in main, after calling reference swap, this is A is equal to 100, B is 5. We can see the changes, okay? Let me tell you how it's working. Again, I'm calling referenced, so up until now, the output is the same. Let me check it. So I'm printing, let's start from here, because we already covered the previous part of the code. I'm continuing here, okay? So I'm printing calling reference swap. Calling referenced blah, blah, blah. And I'm really calling it and sending A and B, but as a reference. So what happens? So we have reference swap, and reference swap has A and B. Both of them are integers. But this A, I'm going to write it again, or no. This A refers to this A here. We don't make a new copy. And this B refers to this B here. We still don't make a copy. And the part, the remaining part is basically the same. So, let's do this stuff here. Again, temp is equal to A is equal to B, B is equal to temp, and so on, okay? So basically, we declare a new variable, which is called temp. But this temp is only linked with reference swap. And I'm saying that this temp is equal to A, so temp is 5. Then I'm saying that A is equal to B, but this A here is equal to B. So I have here 100. What do I have else? And I say that B is equal to temp. So I'm erasing it, I have here 5. Then I'm printing A and B in the end. In the end of this function, A is equal to 100, B is equal to 5. When I delete the function, when the function is finished, everything associated with it is going to be deleted. And when I say associated, I mean only this temp here. Okay, those names might not exist. Those names A and B might be different ones. It might be number 1, so this might be called number 1 here. Number 2, the names will not exist anymore in main. But hey, A and B will exist since they were referenced. So when I go to print it in the main, where we left, when I print A and B, in the end, in main, A is equal to 100 and B is equal to 5. And this is the real swap we are talking about. Did you understand this example? I took a lot of time for this one, but it was critical to understand, okay? Yeah?
So you're first referencing A and B
Yes.
before you define A and B. Wouldn't that give some sort of error?
I didn't understand your question. I'm referencing them?
You're referencing A and B, but
Yes.
you define A and B in the main function, which is after the reference.
No, I'm not defining it. Where I'm defining it? I've defined it in the beginning, A and B in main.
Oh.
I am calling here reference swap, okay? I'm printing it. Basically, it's the same. Okay? I'm not defining it. And they are not defined here. I mean, when I say defined, they are referencing. The name might be the different, okay? So A, in reference what might be called number 1. B might be called number 2. So basically we will have one box with 2 different names. They are called aliases. Okay, did you understand this example? Who understood it? I understood it. All of you, very, very nice. It's important to understand it, and you know now well what's a reference. Now, I'm going to erase this stuff and go with something which is a bit harder, which is called classes. Just 5 minutes. Classes. Object-oriented programming, what it is about. You have heard that the aim of the programmers, for artificial intelligence, if you know what it is to copy the behavior of human beings. Okay? So with programming, what we want to do is to copy the world, to program and visualize and simulate the world we are living in. Okay? So in our world, we have different objects. Okay? We have human beings, we have cars, airplanes, trees, and so on, animals. We are trying to do the same thing in object-oriented programming. Okay? That's why it's called object-oriented programming. And it's very important. So what's the deal with this one? The deal with this one is the following. We are all human beings here. We are all of the same object, which is called human being, but we are different instances of that object. So I'm one instance, you are another, that guy is another, that girl is another instance of human beings. We might have different properties, but generally speaking, our body works in the same way, okay? So these are what object-oriented programming is about and what classes are about. So we might have something which is called class, human. And this class human has some private and public properties. What do I mean with that? You for sure have some secrets that you don't share with others. Okay? So those are private properties. No one knows them. Well, a friend, you might tell to a friend, and it's plausible, you can do it with object-oriented programming, but let's say that no one knows it for the time being. But you have public properties, and everyone knows it, like your name, for instance. While you are a male or female, boy or girl, okay? It's known, it's something public. So you have properties, and you have some abilities, kind of talents. I can play football, I can play chess, I'm good at maths, I'm good at programming, and so on. So this is called object-oriented programming. This is class human, and we might have private, like what we can say, private integer, ID, state ID number. In Turkish, I think you say teca numara, if I'm not mistaken. So state ID, this is private. But public is the name. Or bool, gender. Let me put it as a string also. Male or female. You might have skills that you don't want to tell to others, like hacking. And this skill is a kind of a function. Okay? But you have skills that you want to tell to others, like playing football. Okay? So play football. This is a kind of a function. You may see on it like that. And all human beings might have those skills. I mean, all of them have a state ID, a name. Hacking might not be, someone can hack more, someone not at all, someone is a real hacker, and so on. But we share the same properties, for instance, okay? It will be clear in a while. We will be back in 5 minutes, okay? Not more.